Hi again, everyone. I'm a soccer coach, and some of my players from the team, they asked me to do a Math11 final exam review. So here it is. The first question right here is, write the defining linear functions in the following arithmetic sequence, 99, 103, 107, and continuous. So first of all, we have to remember that formula for the arithmetic sequence, and it is Tn equals a plus n minus 1d. A is the first term, and n is the number of terms. D is the common difference. So to answer this, then basically you need to know what a as the first term is and d. And n and tn, you don't worry about that. N is the number of terms, tn is the nth term, so they want you to leave it what we call in a general form. So tn equals the first term here, which is 99, plus n minus 1. D is what you're adding every time. So here you're adding 4 every time. So that's your common difference. And now 99, I'll distribute the 4 here and there, and I get plus 4n minus 4. And that simplifies to 4n plus 95. And that is your general formula for this. So if you know what n is, you could always just plug it in, and then you'll find whichever term you're looking for. So if it's the 11th term, you just go T11 equals 4 times 11 plus 95, and so on. So for this one right here, it's the sigma notation. So they say k is from 2 to 8. So you know definitely you have 7 terms here, and the reason you know you have 7 terms is you could count them, or you could just go n equals the upper limit minus the lower limit, and you always add 1, and that would give you 7. Yeah. So you have 7 terms here. Now let's find out the first term. So T1, we just sub it, or just expand the sigma notation here, just like write the first 2 terms. So if we sub in 2 for k right here, so we'll have 81 times 1/3 2 minus 1, because we sub in 2 for k. That's the first thing. And 81 times, that's going to be 1/3. So 81 times 1/3 will give you 27. The second term is 81 1/3. Now we're going to sub in 3 for the for k, because it's starting at 2, and you go from 2 all the way to 8 if you want. But you don't want to list all of them. You could just use the formula after that to find the sum, because sigma notation always is asking you the sum. So what's the sum of this expanded series? Now we're going to put in 3 minus 1 there. That's going to give me 2. 1/3 squared is just going to be 1/9 times 81 is going to be 9. So now 9 divided by 27, the second term divided by the first term will give me 1/3. So I know this is going to be a, which is in the formula here, Sn equals a times r to the n minus 1 over r minus 1. So therefore now I could sub in my information here. So the first term is, so what we're finding S7, because we have 7 terms here, and A is 27, R is 1/3 to the power of 7 minus 1 all over 1/3 minus 1. You could do all of this in your calculator. Just make sure, don't forget your order of operations. If I was you, I would just do 1/3 inside brackets to the power of 7, find that out, and then minus 1, and then whatever you get, multiplied into the 27, and then divide the whole thing by negative 2/3, because 1/3 minus 1 is negative 2/3. And that way you could get an answer. Just did that on my calculator and I got 40.5 for this question. So here's a question. It's quite involved. I think you got to do a lot of factoring here. So you got to take, the first thing I would do, I'll take everything and factor it here. So this part right here is a bit easier. So it's going to factor this one. 3 is the greatest common factor from top here and get x minus 4. And then this factors into x minus 4, x plus 2, plus, here you could factor out 2 as well, and you get x minus 1. And the bottom factors into x plus 5, x plus 5, x minus 1. Close the bracket on that. And that's a bracket, by the way. It's just, so when you do this, just cancel the x minus 4 here with the x minus 4, cancel with the x minus 1 with the x minus 1. You could cancel just within each fraction here. You cannot cancel diagonally because you have a plus sign right here. Okay. So what I'm going to do, my Egyptian teacher used to tell me always, Sammy, when you're doing math, put a long line here, and maybe you could use the same trick. Do all your scrap work right here. So the teacher will look at the cleaner side from there. So my scrap work, basically, I'm just gonna factor the 5x squared plus 14x. Sorry, that's, so 5x squared plus 14x minus 19. I'm looking for two numbers that multiply to give me negative 95 and add to give me 14. So that is basically 19 and 5. So therefore it's x plus 19 and x minus 5. They multiply to give me negative 95 and add to give me 14. So therefore doesn't stop right here, right? Because you have a leading coefficient that's a 5 here. It's just, I don't do decomposition, I do it this way. So I divide this by 5, I divide this by 5. Now here they don't divide, so I just stick the 5 in front of the x plus 19. And then here divide, so it gives me 1. And that's the factor for that one. And it's division right here. So that's 5x plus 19 and x minus 1. And the bottom is what multiplies to give me 2 times 3 is 6 and adds to give me 5. That's 3 and 2. So if I'm taking this here, 2x squared plus 5x plus 3, I'm just going to do this a little bit faster. So what multiplies to give me 2 times 3 is 6 and add to give me 5 is 2 and 3 again. So x plus 2, x plus 3. And the leading coefficient here is 2. So I divide both by 2 right there. So I get x plus 1. And this doesn't divide, so I'm just going to write it as 2x plus 3. And that's what you have right here. X plus 1 and 2x plus 3. So now nothing reduces within this, so I'm just going to have 5x plus 19 times x minus 1 all over x plus 1 and 2x plus 3. Now this side here, divide. Here you have 3 over x plus 2 over x plus 5. So we could start doing common denominator here, and the common denominator is x plus 2 and x plus 5. So you know you have to multiply x plus 5 into the 3, so that's going to give me 3 brackets x plus 5 plus 2, and you know you have to multiply the x plus 2 right there, so you get x plus 2 right there. Now we have 5x plus 19 over x minus 1 all over x plus 1 to x plus 3 times, I'm gonna flip this, so this is gonna, the x plus 2 and the x plus 5 will go on top. And you know what I'm gonna do at the same time, I'm gonna start distributing here. So here we're gonna get 3x plus 15 plus 2x plus 4. And from here, I'm gonna get 5x plus 19 times x minus 1 all over x plus 1, x minus 1 times x plus 2, x plus 5, kind of running out of space. Here, this will, when you simplify it, collect like terms, you're gonna get 5x plus 19. Will cancel, and the 5x plus 19 from here will cancel. I was hoping that, why do I have x minus 1 on the bottom here? So this here is supposed to be 2x plus 3. Sorry, I just made a mistake here. This is supposed to be 2x plus 3. And we have x plus 2 right here times x plus 2, x plus 5 all over. This simplifies to 5x minus 19 when you collect like terms. So now you could see this here, and this will disappear. And therefore, the final answer, you multiply the tops together, so you get x minus 1, x plus 2, and x plus 5 in one bracket, or in 3 different brackets, all over x plus 1 and 2x plus 3. Now they say write the non-permissible values. So from here, the non-permissible values, x cannot equal -1 and -2/3. And here, x cannot equal 4 from here, and -2 and -5 and 1 from here as well. So these are your non-permissible values, and this is your final answer. And we'll move on to the next question. So here is a question. It's a parabola in the form y equals a x minus p squared plus q. So given the following parabola and vertex form, complete the following questions, 1 mark each. So we have 5. The last one is asking me to graph it. We'll go to that right after I finish this. So identify the range of the parabola. So if we look at a quick sketch of this, so just quick sketches. Always if you're doing domain, and range, the domain for all parabolas is all real numbers, but the range here, just look at the vertex. The vertex is 3 and 2. So 3 right here and 2 right there. So that's where your vertex is. The vertex, you always get it from here. So the vertex, which most likely they'll ask me somewhere to write the vertex, and they didn't. So I'm just gonna write the vertex right here. The vertex is 3 and 2. So you always change the sign of what's inside the brackets, and that's your P and Q. Y equals AX minus P squared plus Q. Some schools, they use different letters for P and Q. It doesn't matter, just K and H or whatever, the same thing. So if you want to know what you get from here is the vertex, which is P and Q, and the axis is symmetry, which is X equals P. Now, the vertex is 3 and 2. This parabola here, because it's positive, the leading coefficient is positive, it's opening up. So it goes like this. And this is not an accurate graph, just so when we want to tell what the range is, it's good to know how it looks like. So now the range, nothing happens till, because you're scanning on the Y, till you hit 2. And then if you imagine that you have a scanner and you're scanning this way, once you hit 2, your scanner start beeping all the way, because this is going forever to infinity. So therefore, your range is Y is greater than or equal to 2, where Y is a member of all the real numbers. Okay. Identify the direction of opening. As I said, if the A is positive, if A is positive, this opens up. Okay, so opens up. If it's negative, then it'll be opening down. The axis of symmetry, as I said, X equals P, which is that part from the vertex. So X equals 3 right there. Identify the y-intercept. The y-intercept, anytime you want to find the y-intercept where your graph hits the y-axis, anywhere on the y-axis, the x value is always 0. So that's what we do when we're trying to find out what the y-intercept is basically sub n 0 for x. And just do your arithmetics from that formula, and you'll be able to find what that is. That's a 2, sorry. So that's -3 squared, which gives you +9. That's 9 over 2, when you multiply 9 times a half, plus 2 over 1, which gives you 9, plus that's 2, that's 4. So 9 over plus 4 is 13 over 2. So your y-intercept is 13 over 2. So to graph this right here, again, just indicate what we found already. So we found the vertex to be 3 and 2. So 3 and 2 is right there. And we found that the axis of symmetry is X equals 3. So basically, it's the dotted line that you reflect your points, and that's what the axis of symmetry is. Yeah. You don't have to show it really, but if you want to do a dotted line, that's fine. Also, we found the y-intercept to be 13 over 2. So that's that's basically 6.5. So 2, 4, 6, 6.5. So you have a point right here. See that point right here? You could reflect that into the axis symmetry. So you're 1, 2, 3 away from the axis symmetry. So you go 1, 2, 3, and you have your other point. Also with parabolas, there's one way to graph it, is you go out 1, up, you go out 1, and then up 1, and out 1 again, up 3, and out 1 again, up 5. So you could memorize that. However, when we have a half right here, this means you have to multiply now these by half. So what you're really doing for this, you're not going out up 1, you're going out a half here, because the half of the 1 is half. Here you go out 1.5, and so on. And this year, half of 5 is 2.5. So that's what you'll be doing if you want to graph this, because of that A changes this is basically for the y equals x squared. Here you do that. But now since we have a half in front of the, or a is half, then it's not 1, it's you multiply each number here by half to find out how far up you go, but you still go out 1. So if I go out 1 here, I'm supposed to go up 1/2. I'm going to reflect that into the axis of symmetry right there. So we went out 1, up 1/2, and then we go out 1 and up 1.5. So that's 0.5, and that's 1 right there. And then you reflect that into the axis symmetry. So that's 1, 2, 1, 2, and you get point right there. And then you could go out 1, up 2.5. So that's 1, 2, 2.5. And you have those points already there from the y-intercept. And after that, you just kind of wing it, you know. And that's how it looks like. Okay, so this is the answer for that one. Let's go on to the next question. So for this question right here, solve the following quadratic equation using any method you wish. Explain why you chose the method. Okay, so if you have something like this, the first thing you want to do is move everything to one side, equate it to 0. So you write 2x squared minus 15x plus 25. If you want to know what I did, I just moved the 15x to the other side. It becomes minus instead of plus, and I wrote it in the degree order. Now this is factorable, so you're looking for two numbers that multiply to give me 50 and add to give me negative 15. If you're wondering where I get the 50 from, just 2 times 25 gives me 50, and then the negative 15 is the coefficient of x. And the two numbers that do that for me are obvious here, negative 5 and negative 10. Multiply to give me positive 150 and add to give me negative 15. So I rewrite, I'm not going to use the composition. I'm just going to use my own method for factoring. So x minus 5, x minus 10 equals 0. Of course, this is not the exact factor because you have a 2 as a leading coefficient, which means you divide both of these by 2. So here it doesn't divide, so you just write 2x minus 5. And this divides, so it's x minus 5, which gives me 0. And therefore, x equals, this will give me 5 over 2 for an answer. Like right there, you could look at it from right there. It's always the opposite sign. And then x minus 5 gives me 5 as one of the answers. Why it shows the method that I chose? It was easy to factor, or it was factorable. Maybe a word easy. I don't think I'll use this. So you say this is factorable, and that's why it shows this way. If you want to make your life tough, you go ahead and do completing the square. Don't do that because that's you ask him to make a mistake, and completing square is the hardest thing for a lot of students. So don't complete the square and just use factoring. And if it doesn't factor, the next thing is the quadratic formula. You know, the negative b plus or minus square root of b squared minus 4ac all over 2a. In this question, basically what you're doing is you're solving for x. The thing is, this is worth 3 marks, and I think it's easy 3 marks to get, because if you know how to cross multiply, this question is not that hard. So first of all, I'm going to rewrite this. I'm going to use blue color just to change colors. 3x plus 1 over x equals negative x over x plus 1. When you have a negative right here, it's good to put it on one of them. I don't advise to put it on the bottom, put it on top. So when you have a negative right in the front, it's either it goes to the top or to the bottom. Don't put 2 negatives, one on top and one on the bottom, because that's a common mistake that we see students do. Only belongs to one of them. Don't put it on the bottom, because then you'll have to distribute it in here. It's better to put it right on top. Now you cross multiply, you cross that x to the right, and you cross the x plus 1 to the left, you cross the equal sign. So this becomes 3x plus 1 times x plus 1 equals negative x times negative x is negative x squared. Okay, now I'm just going to state my non-permissible values, x, as they asked me here. So x cannot equal 0 and negative 1. 0 is right here, and negative 1 would make this bottom 0, and we cannot have 0 on the bottom. Now, let's start foiling this. We're going to get 3x squared plus 3x plus x plus 1 equals x squared, negative x squared. Now that's 3x plus 4x. 3x squared plus 4x plus 1 equals negative x squared. Now I'm going to move the negative x squared to this side. It's going to give me 4x squared here because you add it when you move to the other side. Plus 4x plus 1 equals 0. You always equate to 0. Now at this stage you factor. This is a perfect square trinomial, so you could factor by going 2x plus 1, throw a square on top, equals 0. If you don't like doing that, you could just factor it by decomposition or the method that I usually use. If you don't see it out right away, you still get the same answer. And therefore, x here equals negative 1/2 from here. That's what makes this 0. So if you want to see how we do that, you just take 2x plus 1, make it equal 0, and then move the 1 to the other side, and then divide both sides by 2 by 2. That cancels, you get that. Okay. I hope you're learning from my videos, and if you're doing so, don't forget, hit that like button. Don't forget to subscribe. Thank you for watching. Please let others know so they could learn as well, especially during these times where a lot of the schools are doing math in a very short time, and kids are having a hard time catching up. Here's your chance to learn more and get yourself ready for next year when school starts, hopefully back into full swing again, and semester or linear system, and you're not doing a math course in 5 weeks, which I feel, I feel sorry for students who have to go through this. But this mess will be over soon, hopefully, and we'll get back to normal life. Thank you for watching again. Bye-bye.